Hi, everyone. Welcome to this webinar. I'm going to be talking today about clean architecture and more specifically about RavenDB. Now, or rather, clean architecture with RavenDB, not about RavenDB specifically. I've been looking into what exactly is clean architecture, and that ended up taking me towards some pretty deep rabbit holes. So the first thing that I figure out is that clean architecture is not necessarily something that is globally applicable. For example, if I'm building a business application, two different people can term very different architectures as clean. From my perspective, I think that the primary definition, the root manner in which we can say whatever architecture is clean or not, is whatever it is amenable to change over time. Over time is typically in the range of 6 months to multiple years. So this is what I'm going to talk about today, and I'm not going to talk about how we did clean architecture inside of RavenDB. I'm going to talk about what happened from the outside, how you can utilize and what sort of feature set and behavior do you want to have. So let's start from the very basic. Software architecture, the fundamental building blocks of your application. And sometimes you can go and look into a piece of software and you find this beautiful architecture. There's actually a book called Beautiful Architecture. And there is another book called Beautiful Code. Highly recommend both of them. Mostly because when you look at them, you realize that, well, there isn't anything special usually here. It's not that we built this incredibly complicated or unknowable machinery. Everything is in its place and everything is obvious and you know what to do. And that is the absolute hallmark of a great architecture. Now, there is a caveat to say here. If I drop you in a project that you have never seen before, and you're expected to provide some sort of a meaningful contribution within a short time frame, and you can't because you have no idea what's going on, that's nothing at all related to the architecture that you have. Instead, the idea of architecture is if you are semi-familiar, at least, you have some rough idea where everything is going, then you have the ability to look at the code, modify it, debug it, operate it, all of the sort of things. It used to be the case that when we talk about architecture, we would only talk about coding. How do I add this feature? But now we are in a very different situation. We're not talking about just code. If I'm building some application, then I have to consider, where do my assets live? My CSS, the GIF file, the HTML. How do I integrate into a CDN? What is my ingest pipeline for data for partners? All bunch of other stuff like that. And as system grow, then it becomes harder and harder to see the forest for the trees. And one of the most horrible things that you can end up having is a forest that is full of unique creations. Each one of them needs its own knowledge. Each one of them needs its own care routine and behaviors and understanding. That's absolutely not what you want. So a good architecture is one where you have a system and there is a structure. And once you got that structure, you're able to go in and understand what's going on. Now, about 15 years ago, I was very heavily involved in the Castle project. This is an open source project, Castle Windsor. It was an inversion of control container. And one of the things that I used to do at the start of every project was to spend a few days setting up the foundations, setting up the container, setting up a whole bunch of scripts and automatic behavior. And I did it for two reasons. One, because I was typically the senior person on the project, so I was responsible for the first few steps. But the second reason was that what I found was that if I laid the foundations properly, if I made sure that this is not just something that you write in a document, you shall write code this way. If I actually turned things around and made it so, here's the structure of the program, this is where you write code, and if you put a class in this namespace inheriting from that base class, it's going to be automatically wired into the container, and then you can start making use of that. And suddenly, we had this self-sustaining process because there was a very small core of automatic behavior that assumed that the structure of the code would be in this manner. And because the cost of making changes to that was not insignificant, most of the time when you want to build a feature, you drew within the line that you were provided. Now think about what it means in terms of how it works for the developer in the trenches working on this project. They can do things the normal way. And that was typically here, the three locations that you typically have to check. Drop your classes, hit F5, everything is done for you. Or they would have to do things the much harder way by wiring everything manually. I think you can imagine how they typically, what they typically chose to do. And that was actually interesting. I'm actually thinking about a very specific project where I did that. And then I left. And then every single person on that team left. And I was a consultant at the time, and there was some nonsense with the end customer because they wanted to bring the project in-house, and we did the handoff, but then the person we did the handoff to left, or you know how it works. 2 years later, I'm coming to the same customer, asking about this project. I'm very proud of this project. It was a major a success for me. It validated a lot of the things, and then I went and got into the most horrible project ever. But going back to this project, I'll go and I ask them, how is it going? And they say, oh yeah, we are good, everything is working. And no one in the team had any idea how the foundation worked. But they were able to continue fixing bugs, adding features, because the structure was there and it supported. Now, this was 15 years ago, more than that now, dear God. But I keep thinking about that as a really great success story. And the fact that they lost the blueprints, but they were able to move on forward was amazing to me. And that's the power of appropriate architecture. That's the power of being able to do things properly. There's also a downside of that, of course. They never run into a problem with the foundation. If they would have run into a problem with the foundation, probably would have to call someone who had more expertise, was able to do so. But I don't think this is such a big downside. I think for a lot of things, having to call an outside expert for when the roof leaks is an acceptable trade-off for not really having to do any sort of ongoing maintenance on a weekly basis. So let's talk about typical architecture. This was more or less the architecture that I had in mind 15 years ago. There was a client, typically a web application. That was the heyday of jQuery, if you remember. If not, I would feel old, so please remember. But there was the web application, lots of stuff happening on the client, but also a non-trivial amount of stuff happening in the application itself. And in the backend, you had a database. And that was pretty much how most applications were built. Sometimes you had a backend integration, so maybe someone would call an API directly, or maybe there was some sort of a export task running or nightly run or something else, but that was pretty much it. And the key was, how do I make those things, the ability to take this horizontal slice across the entire system and make it easy to modify, understand, and operate. And that was basically very much based on the idea of a component-based architecture. So you can write a component and you create a folder here, write appropriate classes with the logic that you want. It automatically gets wired into a REST-based interface. Here you do the same at the front end. You write a page, that page call back to the appropriate API. Then this was interesting. This was interesting because one of the key issues is that it's easy to change here, it's easy to change here, but here, at the time, this was way before RavenDB. That was actually one of the reasons RavenDB exists. I was using the relational database and Hibernate, and one of the challenges was, okay, I want to make a modification to an entity, to my database. How do I do that? So my velocity of development remains constant. How do I do that? So the velocity of going to production remains constant. In this particular project, I could hit a button and in 17 seconds, I would be deployed in production. As a reminder, this is 15 years ago. There is no cloud. There was one server that ran everything, and I was able to script everything to the point where I would go to production multiple times a day. Now, the funny thing about this is that I would actually go to production without ever telling anyone. It was that fast. So maybe a particular request would break, but it would be retried and no one would ever notice. So I could go to a meeting with the client. They would have some questions to me, or some, oh, we are talking about this feature, maybe that feature. And then I would go to, and then we would go to lunch and I would write something and push it to production and hey, we're done. And that is an amazing feeling. And that was, wow. Now, it has been a long time since then. Now, there's still quite a few applications that look like this, but in many cases, the applications we build today are more complex. You have more front ends, more things in here. You have all sorts, instead of having a single business logic layer or location, you have a different way of exposing them for web application, for apps, for other things that you're doing. And in the end, all of that still funnels to a single database. And that's actually interesting because if you think about it, 15 years ago, if I had a big database, I would have to go with sharding. I would have to go with many systems. But the hardware, especially the I/O, but also generally the hardware that we have, means that it is relatively easy for me to hold even large data sets. And by large, I'm talking about hundreds of gigabytes here on a single instance of the database and operate on that. Now, it's horrible for high availability and stuff, but it works. What's the problem now? The problem is that even this is still an extremely simplified system. So now moving into a more realistic view. And this looks something like that. And you have, and this is still very much a partial view of the world. So you have not only your own components, you're integrating with other providers, maybe a provider under your control, maybe providers that are third party, like the authorization service, which is very common. And somehow you have to make sense of this whole thing. And think about it. If you look at an architecture diagram that you need a poster for, how understandable is that? How can I track, debug, monitor, operate, develop, something like that? It becomes increasingly complicated. And then we have other architectural patterns. There is this huge drive from monolith systems to microservices. A monolith is a single big application. Everything in one location. Now, it may be deployed to multiple servers. It may be, but the idea here is that it's all conceptually a single project managed by one team. Sometimes it's broken into modules, but generally there is no deep separation between different parts of the system. So if I'm looking at the customers page, I might be showing some of their order history. And I would do that by just calling to the orders module, or maybe just fetching the data directly. On the other hand, I have microservices. And microservices basically says, oh no, I cannot manage this complexity. I'm going to ensure that every single distinct component in the system is split up and independent. That's going to allow me to manage that separate from everything else. If I have an authorization service and I'm not happy with that, I can switch to a different provider. The customers module should only be concerned with the customer interactions. Order history belongs to somewhere else. So that means that if I need to change, to update, I don't need to deal with this big thing that every change here may impact everything else. I can look into this small piece. And a key aspect here is that there are well-defined boundaries and interfaces between those components. So I can write one of the systems in Go because it makes sense there, and the other in Zig, and the third would be written in .NET. And on the surface, this looks great. There are issues with that. The most common refrain for microservices systems is very simple. You couldn't keep an appropriate architecture when you were writing a single system, typically in a single language. Now you want to try to do the same, but instead of a single system, single language, you have many systems and potentially many languages. What makes you think you will be successful then? On the other hand, being able to surgically operate on a particular part of the system where you have well-defined interface and boundaries between different parts of the system is such a joy. Because you know what's going on. You know, those are the things that I have to worry about. And you have far more freedom. Something to note about this thing, this makes the individual developer life easier because they can focus over this, but it makes the operational team much more complicated because this one is running on this database and this uses Redis for caching, but this one is using Memcached for caching. Why? Because they each made their own decisions. So because this is such a complex thing, you typically end up in one of two things, two ways. Either you end up with a system where most of the things that you're doing are unique flaws, and someone is going to have to carry the bucket for that. Someone is going to be the person who has to maintain all of those systems. Alternatively, you can have a well-defined architecture. And yes, this is for authorization, this is for customers. And we want to have separation between them. But we define our infrastructure and the manner in which we are working upfront. Now, it is possible that there are certain areas of the system where our default architecture just doesn't work. A good example, try to imagine that you are working on a system that has, I once worked on a system that was built around the idea of serving ads. So this system was actually composed of two very distinct pieces. There was the piece that was actually for serving the ads. And that system had a really, really, really strict metrics. Every request had to be handled within 100 milliseconds, and the system has to accept no less than 5,000 requests per second on a sustained basis. That was actually the easy part. The major complexity in the system was in the piece where you configure campaign and ads and exposure, a whole bunch of other stuff like that. And the right thing to do at that point was to split the system. This guy, this is the part where I'm configuring the system. I have 100 users at any given point in time, and performance is non-critical. I can take 500 milliseconds to process the request. No worries. This one is running on 50 servers, and it's being hammered every single second of the day. So I don't need to take the same template and try to apply it in more cases. This guy was written in, I think at the time, Java or C++. I don't recall at the moment. Again, decade or more since that time frame, but it was written with the most excruciating attention to detail, and it didn't do much. The basic idea was that we would effectively spin a node. It would build a bunch of dictionary in memory, and a request would come in with some metadata about the user, and we'd use those dictionaries to do two things. One, to serve the actual ad, and second, to record that that this ad was viewed, so we can actually then charge a customer. That's all. The process for updating the configuration was to update the database, create a new version and spin a new process for this thing, have it read everything from the database. That could take up to a minute or two, and then take over the socket and continue processing requests. So two completely different approaches. And if we were trying to build the business logic and complexity here, it would have killed us, because there was no room for that. But beyond that, once we identify what was the core pieces, what we had to do, we had effectively two separate architectures, but they were made consistent inside their own respective boundaries. Now, let's talk about another topic. This is another common issue that we start seeing today. We are running in a massively distributed systems. Now, some cases you're running on a phone. That's very common today. But I'm not talking about that. This when you run on a phone, you're still basically a client-server system. The phone is just a smarter client. That's all. And the issue here is that what happens when you run in with multiple servers or multiple clusters. The typical example in many cases is what happens if you have a data center in Europe and a data center in the States, where you need to share some data between them, but you also want to always hit a local location. And that's relatively easy. That's obvious. A more complex scenario is what happens if you have a system where you don't have two clusters. You have 200s or 2000s. We have seen scenarios where people are deploying applications to the edge. We have machines on a factory floor, and they process things and operate on them. And now the question now becomes, what do you do with that? How am I able to operate completely independent? I have to be able to operate even if there is no internet connection. At the same time, having to go and figure out what's going on with 200 locations is insane. You want to have some sort of a global insight into that. And to a very large degree, what we're trying to do is to provide you the tools and capabilities in the box, so you don't have to build those sort of things. One of the design principles of RavenDB was the idea that this is an application database. It is meant to take care of your data so you can focus on building the actual business logic around that. And that leads to a really interesting observation. Compute is interesting, and you have many ways of doing that. But at the end of the day, the data is king. And an application is something that happens and modifies all the time. You have so many pieces going on, especially if you go into the more complex architectures. If you're running in a widely distributed systems, if you're running using serverless, and you decompose your system to individual Lambda functions, those sort of things. So at the end of the day, when I'm looking at what's going on, the key here, where is the data and how it works? So I want to present you the most common data flow behavior that you see. There is that. There is just the data, and somehow it reaches to the user. It gets modified some places, and that's how it works. It's actually a lot worse if we're not talking about just a single application. If you're talking about having many different applications that needs to work with the same data sets, how the data is moved and shuffled can make or break the overall system architecture, because you cannot write it. You cannot see it. It's just ad hoc all over the place. So you cannot make changes to the system. We have a question from Avi about the books that I recommended during the beginning. And they are beautiful code. And there is, let's see if I can. It's an orange one, I think. Here it is, this one. So those are two interesting books that goes into the overall architecture, how things are working and why. And you can see it's from everything data-centric application to a self-hosting runtime. There is a wide range of system that this applies to. But anyway, going back to by the way, I haven't talked about this, but if you have any question whatsoever, ask them as soon as you have them. That way I can answer them immediately, at least when I still have all of the context in my head. And I would much rather have you talk to me and have these interactive exchanges instead of me talking to a screen for an hour. So going back to what I was saying, one of the key issues of looking into your system is how are you processing the data? And I want to present you one of the things that drive me crazy. And this is this thing. This is an application. This is more than a decade ago, but here is the front end behavior. Get latest post. This is for, I think, a blog application or something like that. And we have a post repository. This gets injected through a IOC container, inversion control container. Then we have a final method which takes a get post latest for board by ID. So this is a specification pattern. And then we apply this, and we do some operations. Then we map from the entity model to the DTO model, and then we send it out. And just to give you some details about the architecture. So we have a repository implemented by, in this case, an Hibernate, and then we have specification. And oh dear God, here's the actual specification. And this is another one. I don't know. I don't remember. Oh, so now you have to do this, which I don't want to even go into. And then conversely, this is, again, it's getting to the point where showing data on the screen has become a mess. Consider this issue. I want to show some data on the screen. That's the hello world of applications. And I have to deal with repositories and specifications and DTO translation layers. Absolutely insane. So here's the deal. If you have something like that, stop. And stop regardless of what database you're using. About the only reason why you need a repository these days is if you're using I don't know, no database at all. If you're using a relational database, then you have Entity Framework or Hibernate or any or object relation mappers that can help you, that can allow you to express things using strongly type manner. And that also leads to a really interesting observation. One of the reasons why people are moving into this sort of architecture is, oh, I don't want to expose the internals of my application state to the outside world. But the outside world is you. You are the outside world. This is the web application that calls to the backend that would call to the database. And there is a field in the form that we need to fill. And the data for that is in a field under the same name in the database. So this is the most obvious, basic thing to do. And if this is hard, then your architecture sucks. Now, there are reasons why you may need to have more complexity here. Maybe you're running a really high-end system and you need to, and you don't want to hit the database too much. You want to hit a cache. Maybe, I don't know. There is very few reasons why you want to have a large degree of complexity for showing data on the screen. So the ideal here is that you model the system appropriately. And this is part of your architecture. So what you're going to do is to say, okay, I have an application and I'm going to scope the work to the application. So I have an application database and I don't need to have these multiple layers of transformations along the way. So we have some questions. That's awesome. 1 second. Let's answer them immediately. Okay, so we have Lucas. Without repository and specifications, what do you recommend to not duplicate the common queries that are used throughout the application? What queries are used? That's the first thing to ask. And by the way, here is a great way to do that. 1 second. Let's say that I have something like this. So now we have some logic, whatever. Do this. Write it in here, and then whenever you want, you can do something like that. Now, I'm not sure if this is the right thing, because that depends on, so here's what you typically see. No, I don't like these sort of things because I may forget to add this. So there is a question is whatever you have cross-cutting concerns or specific concerns. In many cases, these sort of behaviors are specific to a set of circumstances. In fact, I would say that in most cases, you don't actually care for that. You can put it in line because I don't think that you would be using that a lot of in many cases. But if you have that scenario, do it in this case. Then again, if you want to have a cross-cutting concerns, do something like this. And this is not the exact thing. And now you're done. Now all of your queries in the application are going to be filtered on tenant ID. So Lucas, I hope that this answers questions. We have a question from Denise. What is your opinion on CQRS and mediator needless complexity? CQRS in particular is, why are you doing that? Let's start from there. Because one of the key aspects is that a architecture has to justify itself. If it's not justifying itself, why are you doing that? CQRS is a complex system. You have to split the reads and the writes. You have to have some way of taking the commands and translating them at the end to something that is operational. It turns out that for a lot of things, I would actually say split up. Reads are, again, within the same application scope. Reads are do whatever you want. There should be as little layering as possible between the endpoint and the database, because any layering that you add typically adds a lot of complexity. And commands are absolutely something that you want to have, but you don't have to make it complex. A command object is simply something that you invoke to encapsulate that logic, and that's you're done. And the idea here is that you have something like a Regis customer support request. And the reason you have this is so all of the usual behavior that you have here, which are things such as error handling, retries, login, logic, access controls, those sort of things are centralized, because, and then in here you can just write everything that you need to do the business logic. And you might notice that this is a common theme for me. I abhor complexity, but sometimes you have to have complex solutions. But you don't have to have that complexity in your face. Take all of that complexity, throw that as deep into your application as possible, and expose an interface that you can operate on. The command example is great, because in the command, you get a session, you read and write everything that you need to do, and then you're done. But then again, at some point in time, I say, you know what? I actually want to take this, and this is not actually going to execute the command. This is going to serialize that, execute in a subscription, and release later. I can do this sort of thing now. Okay. So this is Dennis. I hope you answered to that. Amit, what's the difference between this and a repository? Major difference is that this is a decorator to the query. It is not, it is something that you control. Repository is something that you hand to, and then it processes everything. The reason this matters is that, think about this query. I need to be able to do this. In this particular location. If I have this sort of code in the endpoint, I get to control that. I get to manage that. If I get a repository, I have to have some way of expressing those concepts to the repository interface, which force me into a lowest common denominator. Okay. Next question from Carlos. To not duplicate common queries, you can use extension method. Yes, that's correct. Peter, apologies if you already mentioned it, but do you recommend not use separate data, DTO, and domain classes and map them? Is it better to have only domain classes when using DDD, for instance? Okay, so this is a great question. And a large part of that is about what is your application. So let's talk about that for a second. A typical application if you're using the DDD terms, a typical bounded context has its own logic and operations. That is, in general, 2 to 5% of the application. Everything else is about everything else. CRUD operation, report, showing data, sending an Excel spreadsheet about tasks, those sort of things. What I advocate is that you'd have the appropriate boundaries, and the DDD called that the DDD book called it an anti-corruption layer. But the basic idea goes like this. Why are you using a DDD? Using DDD because you want to be able to talk in the business, in the language of the business. You want to be able to do operations that make sense. You're not writing a vacation request. You're submitting a vacation request, which then get approved or denied. Those are not CRUD operations. But at the same time, think about it. What does it mean in my model? And in my model, if I'm looking at the domain aspect, I would say that my commands are the language that I use. That's the ubiquitous language that I use in order to communicate with the business. So I would have a submit vacation request. I would have a deny vacation request. At the same time, to show you the data, which is most of the thing that you're doing, massaging the data from one place to the next. I want to just expose the data as is. Now, the nice thing about this is that I get to do that. I actually get multiple ways of doing that. And again, the whole idea of abstractions is that it will kill you if you have too much. But remember, the fact that you have the data sitting in a particular format in the database doesn't mean that you have to get it out in that same format and expose it directly to the user. But in RavenDB, you have projections, you have indexes, you can traverse the object graph to using includes or load documents, you're in query, you're in indexing. So a lot of that is about not worrying about this. And a key aspect, and Peter, I think this is something that people don't really pay attention to. A key aspect here is that if you work with DTOs and do all of those items, you're losing a lot of features. RavenDB has this notion of change tracking. You can load a document, run whatever code you have, modify it, maybe modify it, I don't know. I don't need to track that. That's the database client responsibility. The session would manage that. And then I would be able to have automatic persistence database when the operation is done. If I'm working with DTOs, I have to take ownership on persistence. I have to know if I changed that, didn't change that, all of those sort of things. If I work with the document entities directly, everything is managed for me. In the same sense, I'm going and writing a query in an endpoint. And with RavenDB, quite explicitly, the whole idea here is that I'm writing the query. In many cases, I can write it in C#. And I think we also support that in TypeScript, something similar, the TypeScript client. But if I'm talking about C#, I'm writing that using native queries, the type checked by the compiler on the endpoint, and then I hit a 5. And the data is there. And the backend database says, oh, I now need to be prepared for these sort of queries. Let me get ready for that. And you don't need to worry about any of that. And a lot of the same things apply in additional occasions. There is the outbooks pattern, where I may need to do an operation that integrate with a third party. which now become this huge complicated thing. Because I want to have a transaction that also includes some third-party operations. So then I can have my transaction, but instead of doing the third-party integration immediately, I'm going to write a command. And that command is going to go into the database and be persisted there as part of the transaction. And then I have a subscription that would take this command and process that and actually do the saga of talking to a payment provider to actually charge your account for this order that you did. Or it would fail the order, and now I have to set up a retry and send you an email and all much further stuff like that. But notice the key aspect here. When the part about taking the order, accepting the order from the client, was relatively simple. Here is the data that I need to persist, and instead of doing everything inline, which would drastically complicate the entire system, I'm moving everything into backend processing. Still transactions, still mostly going to run in the sense that you click the order and an email shows up. Everything is perfect in your email within a few seconds, as you would expect. So that would work. That also ties, I mentioned change tracking, I also want to mention unit of work, because that is important for transactions. Everything that you modify within the system get persisted. And it freezes from this huge amount of persistent concerns that you have to deal with. Felix is asking about query object versus generic repositories. Avoid both of them. I'm going to show you something that I hope would be interesting. This is my blog. This is the code for my blog. Now, this is a 10-plus-year-old project. My blog is really nice, but I'm not doing very much in it. So I'm in terms of the actual logic. So I want you to see something. This is render the homepage. If you go, or maybe it's this one. It's this thing. So notice that somewhere around here, I have the convention that this is the post, this is the index. I have something that apparently I'm doing for the, apparently I'm doing that for the, for the view. But look at this guy. Here is the direct query that I need to do. And I can customize so I know what I'm going to have to do here. And now I'm going to talk about this in a second, but here is this logic. And you can see how it works. So this is actually something that is shared across everything. But there is no mapping. I'm exposing data directly because I control everything in here. Now, it is possible that if I need to do some mapping to hit some specific shape of data, because for legacy, I can do that. But again, look at this guy. Here is me, and think about what it means to review the code or look into what's going on here. This is a more complex system. I'm making two queries here. Let me show you where we're doing, I think it's comments. Okay, here we go. So here is the logic for processing a comment in the blog. So you're doing that, some nonsense about spam filters, and I really like that I'm sending them payment require if they are doing too much. Okay, so here we go. So some queries. This is, by the way, you can see that I just did it a lot, so I add that as an extension method. No real, in this case, I could have probably done something else, but it was easy and cheap. A second, I messed up the location. Here we go. And now we have this guy. Add common task. And some other things that doesn't really matter. So in here, I have to work with the cookies and apparently with the cache for some reason. But notice how almost everything here is give me the details that I want to make a decision if to process this or not. Validate, this is the business logic for this thing. Again, and this is where I'm actually doing the real work. This is a background task. Today, I would probably do that as a subscription. This is just running as a background thread in the blog because honestly, there are not that many comments. And now you can see that we have some behavior, something with spam checking, whatever. So there is logic in here, but the overall architecture is very clear. I don't really need to think about that. Okay, more questions. Prasad is, I hope I'm pronouncing that properly. Prasad is asking, is QoS need to scale up database read performance? Don't bother. Absolutely don't bother. Why is that? When people tell me, oh, I need to scale my database read performance, my immediate answer is why? Oh, because I have to have a lot of reads. What is lot of reads? What is lots of reads? Can someone, by the way, tell me, give me an answer. What is lots of reads under your scenarios? And let me show you something. We had a white paper published about the Rakuten Kobo experience of moving from Couchbase to RavenDB. And just to give you some idea, they're running on the scenario that we tested is 1.35 billion documents, and we tested that with greater than terabyte dataset. Now, the thing that is interesting is this guy. So this is a Raspberry Pi processing 500 requests per second. This is the Raspberry Pi, one Raspberry Pi. There is very little reason why you want to scale read performance. For that matter, I actually forgot to show that. Here we go. This is the post. This is where most people are looking at. So this inherits from this guy. And I want you to take a moment to read what it says here. What it says is aggressively cache everything that is running within these actions. That's it, finito, we're done. By doing that, I can annotate a controller once and everything here is aggressively cached. Which means that there are 0 database queries when I'm loading this page on a normal system. There would only be queries if the data has changed. I guarantee you, this gives me the ability to scale to some ridiculous numbers of loads. And this is actually also really quite interesting because I did not have to change my architecture. I did not have to build a completely new system and completely new CQRS and whatever. I'm just using things normally. So now we have a question from Lucas, which is really, really interesting. If the reads go directly to the database with as few layers as possible, how do you recommend doing authorization? What authorization? That's the first thing that we have to ask. And the reason this matters is that an authorization, okay, we have to explain that. I have this whole big presentation. I'm going into a VS Code and start writing things. I hope this is fine, but I think I'm enjoying this. So here's the issue. You have submit vacation request. Sorry, you have submit, you have deny, you have approve, you have change. Those are done by the employee, those are done by the manager. From the perspective of the database, those are reads and writes. So the question is, why do I, but from the perspective of the application, those are distinct operations. At what point do I apply authorization? In some respect, you do this. If on the entire application, I'm going to say, hey, I need all queries to be filtered using that, that's what I want. But in many other respects, this is a business decision. There is also a really interesting problem. Application operations versus user operations. At one point, I was building a scheduling system. And one of the scheduler system was defined like this. John should not work with Jane because John is a gossip and Jane doesn't like him. Okay. There is a problem. We don't want John to know about that. We just want the schedule to just schedule different shifts. That's less hassle for everyone. So this was defined as scheduling rule. For John. Permissions, deny John. Now, what happened when John clicked the button, schedule me for the next month? The system would then read all of the applicable rules, define the schedule, and move on. The system was acting for John. So the system did not see this rule. So he would keep getting scheduled with Jane. And hilarity ensues, as they say. So the issue here is that the application has access to the data. The user may not. And at that point, this is something that you have to consider inside your application. You can absolutely push that into a query. And we actually see a very good example of authorization in here, where we're saying, give me a public post, which is the authorization. Okay. More questions? No sound? There is sound? Okay. James is asking if there is going to be a recording. Yes, we'll publish that. Alexander is saying, when you use DDD principles and aggregate rules, you don't need to repeat queries and you don't have schema in the DB. To a large extent, yes. If you have DDD, then you have an aggregate root. But I'm not sure that I agree with you because the same aggregate root is being utilized many, many times inside the application. Consider the order in an online shop, which is an absolutely an aggregate route. So in how many places do you want to show it and operate on that? You want to show the customer their recent history, their ongoing shipments. You want to show them the, hey, you bought something like that previously, and not much of other stuff like that. Some of them are different processes, recommendation based on different orders. Probably not, it's not orders. It's the processor result of that. But if you're looking at something like, if you're looking into DDD and aggregates, you will find the purpose of orders to record the order and all of the notification on that, etc. But now I have to, the user goes to the page, and here are your recent orders, and here are the orders that you have a problem with. That maybe you need to pay taxes on that, or maybe we're out of stock. Do you want an alternative option? Stuff like that. So right off the bat, we had multiple ways to occur for the same data. That's leaving aside the fact that I may want to show all sort of aggregate information. How much money have you spent here? Or how close are you to the next customer tier that we have, stuff like that. So I think that you absolutely would be querying the data in multiple ways, but Alexander is correct. Alexander is correct that the actions on the data is typically done at the full root aggregate level. Basically, the ideal manner in which you would operate on that is something like some command, string ID. Let me just fix that so it would have, come on. Public string ID, public, some args, just only type everything, don't do it like this. And then you have ideally you want to get to more or less this level. Now, a couple of things to note here in the commands that you have. You're loading the identity. You are passing any arguments that you have, and now you're in a realm of business logic. The entity would modify its state. Maybe it had some other things such as events that it needs to persist, to raise, whatever, depending on the exact architecture or post that you're working at. And then you complete doing this, you call sessions of changes async, and you complete the unit of form. Esan Akbar is asking, would you please explain how we can use Redis, or is there any feature in RavenDB like Redis? I was given Redis as an example because I didn't want to say just RavenDB all the time. A lot of the features in RavenDB can be, a lot of the things that you do in Redis can be done in RavenDB as well. There are a lot of similarities, but at the same time, you may have a lot of different needs. For example, if you want to have, you can use RavenDB as a key value store, which would run at near memory speed, but would be transactional and all of those sort of things. Robbie's saying that VS Code is better for presentation than PowerPoint. Yes, but as you might have noticed, I get lost when I'm trying to do everything through PowerPoint. I'm enjoying myself, and I think I'm going to continue until all of the questions are answered. But Anyway, I would then go to the presentation, do the things I actually prepare for. Lucas is asking, just to clarify, what you're talking about now is commands. It's more about the queries. So if a user can see a specific piece of data based on roles, auto, etc. Yes, but the key here, and this is very apparent here, that what the user can see is dependent on his role, the action that he's taking within the exact moment. So as a manager, I may submit a vacation request, which then I will not be able to approve because I need to have that from my manager. Except I may be my own manager. So at which point the trying to do that in an authorization layer becomes too complex, but doing that in place for the business scenario that you have become a lot easier. Yoav is asking if you can use RavenDB attachment for object store like S3 or Min.io. Yes, you can do that. There are some advantages on doing that because we can also do things like duplicate eliminations. So if you have two users that upload the same document, we'll only keep one copy of that, and that can save you a lot of disk space. Okay, we are done with the questions. We can move on to slide number 11. Okay, so I think that a lot of those are things that are already discussed ad hoc, but let's do that anyway. So the model is entities. As I said, one-to-one mapping is preferred because at that point, you don't have to deal with the impedance mismatch. Now, there are two impedance mismatch that we talk about. One of them is that your entities and the documents are one and the same. If you compare that to how you use that with relational databases, then in many cases, you have to spend a lot of time just figuring out the optimal way to store and retrieve the data from the database. The second thing is that I absolutely abhor the persistent layers of automapper, DAO, translate 6 different times, etc. The reason this matters is because I want to get to the point where I can change the code and everything immediately happens. And if I'm going this code force approach, that means that I have a very high degree of velocity. And the whole idea is that I want to keep that velocity over time. So I want to throw out anything that would make it slow. Change your queries. The database will adjust. You don't need to do a 2 weeks performance sprint to analyze all of the queries and create appropriate indexes. That's the sort of thing that you can just ignore. So some ideas about the application architecture. The idea here is that we want to have as much as possible to have this cookie cutter. So we have everything in the request scope. I haven't actually shown that here. Where is that? So we have post controller, and here is the raccoon controller. And here we open the session. Where are we actually putting that? I think we're putting that somewhere else because we are reading that from somewhere else. Let me search. Here we go. Okay. So what you see here is I have zero idea what this is doing at this point. And this is probably, just to give some idea, this is code I haven't changed in a decade. But you can see here that we are opening a session. At the end of the request, we are checking if there has been an error. And if an error hasn't been executed, we are going to save the changes. And then we're going to run this. And what this would do, it would basically say, hey, scan for any of the background tasks and execute them. So all of those are things that I don't actually care about. Cookie cutter, I don't need to worry about save changes because it happened by default. There hasn't been an error. There is a single session that is being provided for me. I don't need to think about it. I have the background or output box pattern to deal with long-running systems. Everything is transactions. Again, I don't worry about it. I'm looking at and moving on. Here, this is to address Lucas about security. This is the exact scenario. Submit, update, and approve a vacation request. Those are business concerns, more than anything else. Now, you have the ability to use the events, such as this one, and we have quite a few, to implement a lot of cross-cutting concerns. I want to filter all queries by the tenant ID is the classic example, customer serialization, etc. I want to make a note about data validations. It is tempting to put data validation at the database level, but this is not usually a persistent concern, which is surprising because people hear, oh, I don't want to have my data, I don't want to worry about the data in my database. But the key issue here is that the more data, the more limits you place at the persistent level, such as hooking event, oh, you cannot save a user without a last name, then you end up with a person like me. I don't have a last name. And how do you save someone like that? And there are big list of falsehood programmer believes about X. There is a great one, falsehood programmer believe about names. And a great example, I have a friend whose name is J, the letter J, that's it. And he keeps running into problems with systems that, oh, the name must be at least 3 characters long, stuff like that. Another issue with validation, notice that if you need to do asynchronous validation, or you cannot create more than 10 something per day, so I have to do a query to figure out how much items you purchased today, and if I'm doing an async operation inside a synchronous call, that can really mess you up in terms of what it does to your system. Okay, so let's talk about some data patterns. We have everything in a single database. And that's great because that makes things simple. You have some indexes that you can query. Maybe you have some operations that you do in the indexes, such as aggregating information. A good example is the recommendation system that you can apply through indexes on orders, but there's a whole bunch of examples like that. And the major advantage here is that you have access for the whole thing in a single shot. And it's very easy for you to query A or query B and just run with that. The downside for that is that you end up with everything in one location. It's very easy to get into this sort of mesh. Generally not a problem. Generally very much not a problem. People like to go directly into microservices, etc., but feel the pain first. I would strongly recommend that only go there once you feel the pain that, oh, I need to do something, but the mishmash of concerns that I have is making this complex. And now we have this idea of independent microservices. And the cardinal sin of microservices is a shared database. If you have a shared database and microservices, you have a distributed monolith with all of the attendant complexities and issues, with none of the scaling options, and all of the complexities of microservices as well. To start with, run each microservice as its own database on the same cluster. This is because it makes it much, much easier to manage. And a RavenDB cluster can be quite large, 7, 10, 15 nodes if you need. And that's, again, remember that I gave you this example. Why is that? I'll give you this example. This is running in here on 3 core systems. Sorry, 3 server systems. And this is able to process hundreds of thousands, tens of thousands of requests per second with latency that is under 200 milliseconds. So you tend to not need to scale. If you do, and if you need to scale, at most cases, you can increase the cluster size because simplify operations. There is a caveat here if you need to scale out for geographical locations. Sometimes, this service must reside within the bank, but most of the system is outside the bank. So now you have to have the data reside within the bank and outside the bank, and etc. And now there is a really important issue here. If you never access another database, how do you get data that is owned by another service? There are 2 options. One of them is that you call to the other service. It is possible that it's complex, it creates temporal coupling between services, etc. On the other hand, you can have the service push data to you. Now, in this case, this is important. Everything I said so far was about use the same model for your application. And within the application, you don't want to have layers of abstractions. Between services, you're typically not going to expose the data as is. Well, to be fair, you might expose the data as is in V1. But the whole idea is that once you expose the data, then you create a contract. This is how I'm exposing the data to you from now on. And RavenDB has the facility to make it happen even as you're modifying your data. Even if you're mutating the internal representation, the external one that you push to other systems remains the same. Okay. And let's see. So, by the way, this is a very common thing to do in order to share data between services through the RavenDB ETL. Large part of this is about how do I do reporting and generally queries. RavenDB is an OLTP database. It means for processing transactions. You can do aggregation from MapReduce, and this is an amazing way if you know what you're doing up front, because RavenDB can do all of the work up front and then is really, really fast for query. If you want real queries, don't use RavenDB. And again, this is about make sure that you use the best tool for the job. We have Power BI integration, so you can just set it up and run, and basically give the business analyst the ability to run their own queries. You can push the data out from RavenDB to other locations. And okay, so Rob is asking, can you do a quick example of how to push data via contract between 2 RavenDB servers? Sure, why not? Okay, so here we have one database, and I'm going to call that employees. Now, in this case, let's say that I have these employees, and you can see how they look like. I need to push data from this database to the employees database, and I can do it like this. To RavenDB ETL. So this is basically the routine of figuring out what I want to send. And now I'm going to do this. This.name equal just to give you some context. This is the raw document. And so apparently we have a UI bug. And now you can see this is what we do. And you can see that the name is different. And I can do whatever I want because I can write any JavaScript that I want here. And now I'm done. Okay. Now I'm going to go here. And here are the employees. Notice that we have a name property here, not first name. Now, here is an interesting aspect. Once I've defined that, this is now in action. This is an ongoing operation. This is not a one-time thing. So now at that point, you have exposed a particular data out to the employees. I can now go and make changes here, adjust the ETL script, and keep the same thing. Peter is asking, in your opinion, is it okay in your opinion to have reference to object in a different microservice DB, say of orders and the customers, would you probably need to store order IDs? You know, that is a great example. So let me do this. So this is the orders database, and I'm just going to very, very quickly create a new one. And what I'm going to do here, okay. So now let's go to orders. And now you can see that they have companies and employees here. So it's very typical to want to show some data, right? From orders, and this isn't really user-friendly. So let's do this. Now I'm going to push. By the way, assume that each one of those is a separate thingy. So now I have companies and where is, I'm trying to figure out what data do I want to show here. And so what I've done now, I can go to orders. You can see these guys. But it's important to understand that now I have this. Second. Select order at. Not fun, right? And also what happened now. Now I have defined within the space of a few minutes ETL processes that push data from the relevant owning servers and I'm giving the orders database the ability to show to the user the exact data that they want, because this is what they care about. They don't care about company number 2. And that means at the same time, notice what I've done here. I don't have anything actually operational here. I don't do much. This is just there to be able to enable the user to manage that. I have another question. Can you do full text search right in RavenDB alone? Why would I want to use Elasticsearch? The question is, yes, you can do full text search directly inside of RavenDB. The typical reason why you want to use ETL to Elasticsearch is if you have an existing investment, you want to do Kibana, you want to do those sort of things, and instead of utilizing the built-in capabilities. There are certain clients that are using, they already have that investment and they want to keep on using that. Sometimes it's just about, I want to push that from my system to someone else. And again, that's all about the maintaining the clean architecture. I don't need to rebuild everything if the infrastructure is already in place. Okay, moving on. So notice this guy, he's a suspicious person and he's not going to have a clean day. Do not do that. Use ETL, use something else. And this is a really good quote. Tall fences make for good neighbors. If you have good separation between system and services, you're much better systems. One more questions. Would you characterize RavenDB full text search as being full features as Elastic's text search? The answer is yes. At the current time, both of us, both Elasticsearch and RavenDB, are using the same underlying library, Lucene. So pretty much everything that you can do in Elasticsearch, you can do in RavenDB. In many cases, it's simpler because RavenDB would be the system of record and you don't need to schlep your data from one location to the next. Elasticsearch has a lot more features specific around search, but RavenDB has features such as highlight, facets, full text search, full scene integration, all of those sort of things there. You can see some of the examples of full text search here in the demo.ravendb.net. And somewhere. Here we go. So some example of how you can do certain complex operations. And again, the whole idea is that everything is in one shot. You don't really need to think about it or integrate with something else. Okay. There are some features that we keep talking about, full text search subscriptions, but there are a bunch of features that are there to solve very specific problems that it is worth taking the time to know because they can mean that you don't really need to think about something. Revisions, for example, if you need to have an audit log, that can be as simple as turning a feature and you're done. You have an audit log. And that's audit log that is meant to be to meet the requirement of regulatory bodies. We have a feature such as expires. You could just tell RavenDB, hey, this document should go away, poof, in 3 hours. And it will do that. And which is important for many interesting scenarios, you can imagine. There is this guy, which is really interesting because this one combined with subscriptions give you the ability to process timeout and features in the future. So you can write a document and settings up. So I want to receive this document in my subscription in 3 days. Attachments, counters, and time series, I think we talked about it a lot, but they don't see enough use because people try to use time series in documents instead of dedicated, and the performance and the capability that we can push into those are much better. attachments in particular, if you have any case where you have to store large strings or byte arrays inside your documents, and they're not operational, use an attachment. A good example, by the way, might be a blog post. I have some blog posts which are 400 kilobyte in size. If I had lots of them, then it would make sense to store the post body as an attachment. Notice that this doesn't mean that I cannot still utilize features such as indexing the attachment's content, because that's a feature that will be handled. But it means that I would be able to split the document. The post body as an attachment would be separate and only retrieved when I actually want that. Operating in scale. Sometimes you have multiple clusters and you want to have the same data, but still be able to operate on the local state. That's quite easy to do in RavenDB. You can define full replication between all of those clusters, and then RavenDB is responsible for handling everything for you. The one thing that you have to take into account is that you have to define the data ownership rules. So the users in Europe are being modified only in Europe. They can be read and in other locations, but their owner is the European one. And Deshan has been kind enough to put the indexing attachments in the chat if you're interested in looking into exactly how that works. Okay. Operating in vast scales, if you have hundreds, thousands of locations. Clinics, branches, we actually have quite a few customers who are putting us on ships and in cars and trucks. The basic idea is that we are cannot rely on having internet connection or having the cloud available. So we have a cluster in each one of those locations. So we can share data between them, but work independently. So we have external application and we have pool application. External application is great if you have a small number of clusters. Pool application, if you have hundreds of clusters, but you want to push all of them into some central location, that you can handle that. This is the hub and spoke model, or alternative, you can have a full mesh where there is no central node, but the data is fully replicated. This is typically used if you have a branch model and you have like 20 branches, but there is no real proper HQ location or something like that. Another thing that is important in this case, in many cases, what you actually want, you don't actually need all of the data in operational manner. You want to do that for reporting, at which point you can use the OLAP feature and push data to something like S3 or Azure Data Lake, and then process the data from there in something like Presto or Athena. Okay, and what happens if you don't have any trust? You can see this guy who is apparently cheating, and we have this notion of filter application where you can share some of the data and you can accept some of the data. And the nice thing about it is that you can also apply that. So I don't trust this guy, so I'm going to have very strict limits on him. But this is trustworthy, so I'm going to give him more data. And the idea here is that you can publish data to a particular customer, to push to an edge location, to get data from a particular edge location. It also works very nice if you have to worry about the physical security of your system. One of the things that is important for, I gave the mention of cars and trucks and things like that. So if you're storing details about the truck, what cargo I have, what route I'm taking, something like that, then you have to understand that, hey, if I'm keeping the data on the truck and someone takes the laptop from the truck, they have access to the data. And at that point, you can say, okay, I have to worry about only sharing the data for that particular truck, so it limits the blast radius. Another thing that you can do, which is really interesting, you can use the ETL not to push real data to a service data in the contract form, but to anonymize data to a UAT system, to a QA location, so you can work with realistic data sets, but without having to worry about data privacy, anonymization, and all bunch of other things that you have to deal with. To close things up, and I'm almost done, I know this has been actually quite long. RavenDB was meant to be an application database, which means that the application has full access. We have the ability to say, oh, you have read-only access to this, but for the most part, the design is you have access to the database, you have access to the full data in the database. The unit of access is the database level. You can apply filter permission at the database level through filter applications, through what certificate you provide, ETL that push only some data. But beyond that, once you have access to the database, the idea here is that you're not giving someone direct access to the data. Typically, there is an application sitting in the middle. If you want to show a user some part of the data, then the typical way to do that was create a dedicated database for that and push the data to that, because that's the boundary of trust. There is a whole bunch of features around pushing and managing the data, the flow of the data, because that's important, because that's how we manage to do things without going crazy. And again, remember, if you have 1,000 unique flowers, you cannot understand that. But if you have a 1,000 identical clone, you can start the clone wars in Star Wars. There is a huge amount of features that are meant for very specific scenarios. Be it lazy loading to reduce the number of round trips, to refresh to allow you to process things down the line. And in many cases, they can dramatically reduce the amount of complexity that they have to deal with. And one last thought before I open the floor for more questions is that if you are running an architecture with lots of layers and catering to the lowest common denominator, then you end up being reaping the least benefits, basically. And you have to implement a lot of things on your own. Or you end up with the worst of both worlds. Oh, I have to use includes, so I expose that in my repository interface, but now I tie to RavenDB, but with more steps in the middle. And with that, do you have any questions? I will drink some coffee in the meantime. While you think about more questions, I want to give you some reminders. This is a great resource to learn about RavenDB because it's basically all of the code samples you want to look at in various languages, and you can look into that. If you haven't run RavenDB, you can do that absolutely free, both in the cloud and on-premise. So run it and get started immediately. And if you have any questions you would like to talk to us, just give us a ping. We'll be very happy to talk to you. And with that, yes. So the latest version has leveraged automata in Elasticsearch. This is a question from Felix. And yes, this is a better way to process some things. We actually have a long-running project called Corax that is aimed to replace Lucene because we want to have fuller control and have something that mesh more realistically with our architecture and preferences. You can actually keep track of that in here. This is called Corax. And this is now to the point where you can run this and it will give you actual queries running on Corax. And I'm really excited about it because that gives us a lot more options for optimization and performance. At some point, we'll probably have a bigger divergence in features. Most of our users are interested in queries and full text search as a sidebar, where Elasticsearch is focused on full text search as the primary goal and queries as the secondary one. Any more questions? So Peter, thank you, and thank everyone for joining me and listening me talk for so long. Have a great day. Goodbye.